Assalamu alaikum students. Today our topic is regarding electric potential. Lastly we have read about electric field. What was electric field? Electric field was simply if you are having a charge, let it be positive charge, then the space or region around this very charge. If this is the space, this is the region within which it is force of attraction or force of repulsion is felt. Force of repulsion is felt by positive charge. Force of attraction is felt by negative charge. So within this very boundary, we can say there is a field. That very field is called as the electric field, up to which that very it can experience a repulsion force for positive charge and attractive force for negative charge. So the space or region around a charged body. Now we are having another term that is called as electric potential. What is actually electric potential? Now, if we are having, we will take this vary as a charge, and this charge we call as source charge. Why source charge? This we called as what? Source charge. Because we have to find out the potential of this very mm, electric potential of this very charge. Source charge by source charge means having a large magnitude, and we will take a test charge. Test charge is that very charge whose what I mean to say potential is very small. So what I have to understand you now, I have to make you understand electric potential. Electric potential is defined as amount of work done. If we are having a unit positive charge, we are having a positive charge, but that is outside the field. This is the field up to which its influence, the source charge influence can be felt. But outside it, there is no force, there is no field for this very charge. Here, no field, no, there is no field. But we are having a positive charge outside this very boundary, outside this very electric field boundary. So if we are having a unit positive charge whose magnitude is very small, so if we have to bring this very charge from infinity, it is infinity to any point, let this be the point within the electric field, or this be the point within the electric field, or this be the point within the electric field, this be the point within the electric field. So mo, what is actually then electric potential? Electric potential is defined as the amount of work done. It is what? Amount of work done to bring a unit positive charge from infinity to that given point within electric field. Listen once again. Now we are having this as a source charge. By source charge we mean we have to calculate its electric potential. It is obvious as you are going to hear. If we are having a positive charge and that is very much close to here, we are having a positive charge very much close to this very source charge. The positive charge which we take close to it is having a small field, small magnitude. So there will be a large force of repulsion between two. Or we can say if we have to take a charge from infinity very much close to this very source charge, we have to do a lot of work. If we have to take this very charge to this very point, which is far away from this very positive charge, let me place point A, point B, point C, point D. If I have to take positive charge from infinity to point A, a little amount of work is done because point A is very far away from positive charge. But if we have to take that very same positive charge from infinity to point C, which is very much close to positive charge, then a large amount of work is done because that means there is a large amount of potential. So What I mean to say, it is simply defined as amount of work done, how much work we have to do to bring that very unit positive charge from infinity to this very point, where we have to calculate the electric potential. If I have to calculate the potential of this very charge, which I will place the capital Q, if I have to find the potential of charge Q at point A, so I will say how much work is done to take unit positive charge from infinity to point A. If I have to find out potential of charge Q at point C, so I will see how much work is done for unit positive charge to take it from infinity to point C. It is obvious a large amount of work is done to take the positive charge from infinity to point C as compared to take it from infinity to point E. So this very thing is called as electric potential. Electric potential is simply defined as the amount of work done to take a positive charge from infinity to that very point where we have to find out. If we will say W is the amount of work done. W is amount of work done. Amount of work done to take charge from to take charge from infinity to point to a fixed point. If W is the amount of work done to take charge Q, I will say from infinity to a fixed point, then electric potential is equal to work done by charge. That is simply electric potential denoted by V is equal to W by Q. This is how we are going to define electric potential. So electric potential at a point is defined as amount of work done to take a positive charge from infinity to that very point. It is denoted by W, and if you are going to see its units, it will be simply its units will be W, that is joule, and charge its coulomb, that will be simply joule per coulomb. That's electric potential, and that's called as the volt. Joule per coulomb, that's called as the volt. So how you will define 1 volt? Electric potential is said to be 1 volt. Thus, electric potential is said to be 1 volt if 1 joule of work is done to take 1 coulomb of charge. 1 coulomb of charge from infinity to that point. So simply amount of how much work is done to take a charge from infinity to that very point, that is called as what? Electric potential. It is SI unit is joule per coulomb, that is called as volt. Now we are having another term which is related, that is called as electric potential difference, which is very much related to the same topic. What is now electric potential difference? If you are going to see closely how what is electric potential difference, so that will be now electric potential difference. Now there is a slight difference. What difference? If we are having this as a positive charge and this is the field around it. Now if we are having 2 points, this is one point A and this is point B. So here the potential will be VA, here the potential will be VB, because they are at different distances from the positive charge. But if you will take a sphere around this very positive charge, whatever is the potential at point A, same will be here, same will be here, same will be here at every point C. But whatever is the potential at point B, same will be here, same will be here, same will be on these very points. But there is a potential difference between A and B. At A it is VA, at B it is VB. Now there is electric potential difference. Electric potential difference simply defined as amount of work done to take unit positive charge from one point to another point within the electric field. Now it is again the same difference, but the difference where lies? Now both the points are within the electric field. How much work is done to take unit positive charge? Work done to take unit positive charge from one point to another point, from one point to another point within electric field, within electric field. So it is denoted by delta V. Delta V will be simply, you can say it, how much potential difference here, how much potential difference here. So it will be simply, as we will say, if W is the amount of work done to take charge from B to A, if W is the amount of work done to take charge from one point to another point, one point to another point, then simply you can write it out, WA minus WB. So WA minus WB, that is delta V, and as it is delta, then it will be simply W by Q. It is delta V, not W. It's delta V, change in potential difference, because here it will be VB, here it will be VA is greater than VB. So VA minus VB, that will be W by K. Again, it is having the same units. It is having the unit joule per coulomb, and that's called as volt. Now you have to define here 1 volt. How you will define? So 1 volt is defined as amount of work done to bring a unit positive charge from one point to another point. Now listen, in the first case we define amount of work done to take unit positive charge from infinity to, if we have to take from infinity to point B, that will be potential at point B. If you have to take it from infinity to point A, that will be the potential at A. Now what is the potential difference? The potential difference is within the 2 points within the electric field, between the 2 points within the electric field. So it is defined as amount of work done to take unit positive charge from one point to another point within the electric field, and that is denoted by delta V is equal to W by Q. It is having the same units, volt. 1 volt is defined as when 1 joule of work is done to take unit positive charge from, when 1 joule of work is done to take 1 coulomb of charge from one point to another point within the electric field, that is known as 1 volt. So this was all regarding the electric potential. Tomorrow we will be with another lecture. Till then, Allah Hafiz.